Ground rods should never be placed in a trench used for septic systems, water supply lines, or gas lines. Since ground rods are installed for the purpose of grounding electrical systems and providing a path to earth for fault currents, it is important to ensure that they are not in contact with any other conductive materials that could potentially compromise their effectiveness. If a ground rod is placed in a trench used for a septic system, there is a risk that the rod could come into contact with the septic tank or other components of the system. This could create a path for electrical current to flow into the septic system, which could pose a safety hazard. Additionally, the septic tank could provide a source of moisture that could corrode the ground rod, reducing its effectiveness over time. For similar reasons, ground rods should not be placed in trenches used for water supply lines or gas lines. If a ground rod comes into contact with a water supply line, it could create a path for electrical current to flow into the water supply, which could pose a health hazard. If a ground rod comes into contact with a gas line, it could create a path for electrical current to flow into the gas line, which could pose a fire and explosion hazard. The best practice for installing ground rods is to drive them into the ground at a location that is not near any other conductive materials. This will ensure that the ground rods are able to provide a safe and effective path to earth for fault currents. The purpose of a grounding system is to provide a low impedance path for fault current to return to the source. This helps to ensure that overcurrent devices, such as circuit breakers or fuses, will trip and energize the circuit in the event of a ground fault. A ground rod is a conductive rod that is driven into the earth to provide a connection to ground. The ground rod is typically made of copper or copper-clad steel and must meet specific requirements outlined in the National Electrical Code, or NEC. The NEC provides detailed requirements for grounding and bonding to ensure electrical safety. The minimum length of a ground rod is typically 8 feet, and it must be driven into the earth so that at least 8 feet of its length is in contact with the soil. The location of ground rods is critical for safety and effectiveness. Firstly, ground rods should be located where they will not be subject to physical damage. Secondly, they should be accessible for inspection and maintenance. Thirdly, they should be located away from any underground utilities such as water pipes, gas lines, and septic systems. The reason for keeping ground rods away from septic systems, water lines, and gas lines is to prevent electrical hazards and corrosion. If a ground rod is placed near a septic system, there is a risk that the rod could come into contact with the septic tank or other components of the system. This could create a path for electrical current to flow into the septic system, which could pose a safety hazard. The moisture and chemicals present in a septic system can also corrode the ground rod, reducing its effectiveness over time. Similarly, if a ground rod is placed near a water line, it could create a path for electrical current to flow into the water supply, which could pose a health hazard. If a ground rod is placed near a gas line, it could create a path for electrical current to flow into the gas line, which could pose a fire and explosion hazard. The NEC specifies requirements for the spacing of ground rods. If 2 or more ground rods are used, they should be spaced at least 6 feet apart. This helps to ensure that the ground rods are effective in providing a low impedance path to ground. In addition to ground rods, other types of grounding electrodes may be used, such as ground plates and underground metallic water pipes. Ground plates are typically made of copper or steel and are buried in the earth to provide a connection to ground. Underground metallic water pipes can also be used as grounding electrodes if they meet certain requirements outlined in the NEC. The NEC also requires that the grounding electrode system be bonded to the building's metal frame, metal water pipes, and other metal parts that are likely to become energized. This bonding helps to create a common ground potential throughout the building, which reduces the risk of electric shock. Proper grounding and bonding are essential for electrical safety. By following the requirements of the NEC and best practices for installation, it is possible to create a safe and effective grounding system that will protect people and property from electrical hazards. When installing ground rods, it is important to consider the soil conditions. The soil resistivity can affect the effectiveness of the ground rod. Soil resistivity is a measure of how well the soil conducts electricity. Low soil resistivity is desirable because it allows the ground rod to make better contact with the earth and provide a lower impedance path to ground. Soil resistivity can be affected by several factors, including moisture content, temperature, and the presence of salts and other minerals. In areas with high soil resistivity, it may be necessary to use multiple ground rods or other methods to achieve an adequate grounding system. There are several methods for testing the effectiveness of a grounding system. One common method is the 3-point fall-off potential test. This test involves driving two auxiliary ground rods into the earth and using a ground resistance meter to measure the resistance between the main ground rod and the auxiliary ground rods. The fall-off potential test can provide valuable information about the effectiveness of the grounding system and can help to identify any problems that need to be addressed. Another important aspect of grounding is the use of ground fault circuit interrupters, or GFCIs. GFCIs are devices that are designed to protect people from electric shock. They work by monitoring the current flowing through a circuit and quickly interrupting the power if a ground fault is detected. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas, where there is a high risk of electric shock. The NEC provides detailed requirements for the installation and use of GFCIs. In addition to grounding and bonding, surge protection is another important aspect of electrical safety. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges, such as those caused by lightning strikes or power line disturbances. SPD work by diverting the surge current to ground, which helps to prevent damage to sensitive electronic equipment. SPD are available in a variety of types and sizes and can be installed at the service entrance or at individual pieces of equipment. The NEC provides requirements for the installation and use of SPD. Regular inspection and maintenance of the grounding system are essential to ensure its continued effectiveness. Ground rods and other grounding components should be inspected periodically for corrosion, damage, and loose connections. Any problems that are identified should be addressed promptly. It is also important to test the grounding system periodically to verify that it is still functioning properly. When working with electrical systems, it is important to follow all safety precautions. Always de-energize the circuit before working on it, and use appropriate personal protective equipment, such as gloves and safety glasses. If you are not qualified to work on electrical systems, hire a qualified electrician. Grounding is a critical aspect of electrical safety, and it is important to understand the principles of grounding and bonding. By following the requirements of the NEC and best practices for installation, it is possible to create a safe and effective grounding system that will protect people and property from electrical hazards. Remember to always consult with a qualified electrician or electrical engineer for specific guidance on grounding requirements for a particular application. Never compromise on safety when it comes to electrical systems. A well-designed and properly installed grounding system is an investment in safety and can help to prevent electrical accidents and injuries. The grounding system is not just about protecting people, it is also about protecting equipment. A good grounding system can help to prevent damage to sensitive electronic equipment from voltage surges and other electrical disturbances. In addition to the NEC, other standards and regulations may apply to grounding systems in certain applications. For example, the telecommunications industry has its own set of grounding standards that are designed to protect telecommunications equipment from electrical hazards. It is important to be aware of any applicable standards and regulations and to comply with them. When designing a grounding system, it is important to consider the specific requirements of the application. Factors such as the type of equipment being grounded, the voltage level, and the environmental conditions should be taken into account. A qualified electrical engineer can help to design a grounding system that meets the specific needs of the application. The grounding system is an integral part of the overall electrical system, and it should be treated as such. Proper grounding is not just a matter of compliance with codes and regulations, it is a matter of safety and reliability. A well-designed and properly installed grounding system can help to ensure the safe and reliable operation of electrical equipment and can protect people and property from electrical hazards. Remember that electrical codes and standards are constantly evolving, so it is important to stay up to date on the latest requirements. Continuing education and training are essential for electricians and other electrical professionals. By staying informed and following best practices, it is possible to create a safe and effective electrical system that will serve its purpose for many years to come. When selecting ground rods, it is important to choose the right size and material for the application. Ground rods are typically made of copper or copper-clad steel. Copper ground rods are more resistant to corrosion, but they are also more expensive. Copper-clad steel ground rods are a good compromise between cost and corrosion resistance. The size of the ground rod is also important. The NEC specifies minimum size requirements for ground rods, depending on the type of grounding system. It is important to choose a ground rod that meets or exceeds these requirements. When driving ground rods, it is important to use proper techniques to avoid damaging the rod or the surrounding soil. The ground rod should be driven straight into the ground, and it should not be bent or damaged during installation. If the ground rod encounters an obstruction, it should be removed and reinstalled in a different location. After the ground rod is installed, it should be connected to the grounding electrode conductor. The grounding electrode conductor is a wire that connects the ground rod to the building's electrical system. The grounding electrode conductor should be sized according to the requirements of the NEC. The connection between the ground rod and the grounding electrode conductor should be made using a listed connector. A listed connector is a connector that has been tested and certified by a recognized testing laboratory, such as Underwriters Laboratories or OL. Using a listed connector ensures that the connection is safe and reliable. In addition to ground rods, other types of grounding electrodes may be used, such as ground plates and concrete encased electrodes. Ground plates are typically made of copper or steel and are buried in the earth to provide a connection to ground. Concrete encased electrodes are made by encasing a bare copper conductor in concrete. Concrete encased electrodes are often used in new construction. The type of grounding electrode that is used will depend on the specific requirements of the application. In some cases, it may be necessary to use multiple grounding electrodes to achieve an adequate grounding system. The use of multiple grounding electrodes can help to reduce the overall impedance of the grounding system. The impedance of the grounding system is a measure of how well the grounding system conducts electricity. A low impedance grounding system is desirable because it allows fault current to flow easily to ground. The NEC requires that the impedance of the grounding system be low enough to allow overcurrent devices to trip quickly in the event of a ground fault. The impedance of the grounding system can be affected by several factors, including the type of grounding electrodes used, the spacing between grounding electrodes, and the soil resistivity. Soil resistivity is a measure of how well the soil conducts electricity. Low soil resistivity is desirable because it allows the grounding electrodes to make better contact with the earth. Soil resistivity can be affected by several factors, including moisture content, temperature, and the presence of salts and other minerals. In areas with high soil resistivity, it may be necessary to use special techniques to improve the effectiveness of the grounding system. One technique is to use ground-enhancing materials. Ground-enhancing materials are materials that are designed to improve the conductivity of the soil. These materials can be used to surround the grounding electrodes to improve their contact with the earth. Another technique is to use deep-driven ground rods. Deep-driven ground rods are ground rods that are driven deep into the earth to reach lower resistivity soil. Deep-driven ground rods can be an effective way to improve the grounding system in areas with high soil resistivity. Proper grounding is essential for electrical safety. By following the requirements of the NEC and best practices for installation, it is possible to create a safe and effective grounding system that will protect people and property from electrical hazards. Remember to always consult with a qualified electrician or electrical engineer for specific guidance on grounding requirements for a particular application. Never compromise on safety when it comes to electrical systems. A well-designed and properly installed grounding system is an investment in safety and can help to prevent electrical accidents and injuries.